Hello. Hello. फोन को साइलेंट पे रखिए सुनिए
Welcome to day 2 of our international conference, Track4. For this session, I will be the moderator, and with me I have Dr. Ravi Kumar, Assistant Professor, AIT. This session will be chaired by Dr. Kalka Dubey. Sir has already joined. Dr. Kalka Dubey is currently working as an Assistant Professor in the Department of Computer Science and Engineering at Rajiv Gandhi Institute of Petroleum Technology, MET. He received his PhD degree from IIT Roorkee in Cloud Computing Specialization. We welcome you, sir. We have three keynote speakers in this track, followed by presentations. Our first keynote speaker for this track is Professor Sushant Kumar Mishra. We welcome you, sir. Professor Sushant Kumar Mishra is Professor and Dean in the School of Language and Literature at Nalanda University. His areas of expertise are translation studies, comparative literature, semiotics, Indian and European traditions, having approximate 25 years of teaching experience. Sir is having two PhDs, one from JNU and another from Delhi University. Sir, I invite you to deliver your keynote speech.
Okay. So you can hear me? Am I audible?
Yes, sir.
Yes, thank you. Thank you. So today we are going to discuss in the larger context of language analytics, the issues related to language pairs and what kind of future growth can we expect in terms of language analytics and overall intermarriage between technology and language studies. So, as we know that in contemporary times, language has become a key factor in a lot of research. A lot of technological innovations are happening through language because once we need to reach the global market, whether we call it market or in general the global audience, we have to cross the barrier of language. Until now, there is an advantage that we could work through English, but even English is not sufficient anymore because it may be a language of research or with which we can interact with the intellectuals. That is a possibility. However, we need to reach the common people also. The technology and technological advantages have to respond to the requirements of common people, as well as we have to understand their requirements so as to respond more effectively. And in this situation, we have not only globalization, but we have a concept of localization coming with globalization. And that is a very important concept in our times, in which the new kinds of language analytics, the new ways of comparing the language data that we get, or different kinds of language data that we need to collect. And we have to work upon all that language data with a novel understanding. So first of all, if we take the language pairs, which are the language pairs that we need to work upon. Of course, you would have got a very important department of languages, but this language department has to work closely now with your computer experts and then collect and make data available related to Indian languages, not only language, but languages. Until now, there was a debate. Let's say if you are stationed in Bihar, my university or your university, we are presently in Bihar. So what are the varieties of languages? It's not only a question of any constitutional status of language, but the varieties of language with which we are dealing. That becomes very important for us. And in that context, we have to also understand not only Indian languages, but there are some foreign languages also that come into our context. Now, let's say when I use the word foreign language, what do we understand by foreign language? One simple ordinary definition would be that a language that is spoken in any country abroad and is used only in those societies which are out of our sovereignty frontiers. Yes, that is definitely a definition, but there are questions related to this. For example, there are languages which we understand and we also speak in some parts, yet they are foreign languages. And a very common example would be Nepali and Bangla from our context. There are other sides of India where you again find it. And then there are languages like Nepali and Bangla, two examples I can give you. But there are other types of languages we understand, but we don't interact with the societies. For example, Sinhalese. If we talk of Tamil, let's say Tamil of Tamil Nadu and Tamil of Sri Lanka may have something in common, definitely. At least the name is the same with internal variations. But Sinhalese is very much an Indo-Aryan language that a lot of us will be able to understand. At least there are similar words that you find in Bengali, in Odia and Sinhalese, but the language is spoken in a different country. Do we have data on that? Do we consider that a foreign language? Yes, once upon a time it was studied in India. Later, perhaps, there was a department in BHU, so later perhaps they could not find anyone who could teach Sinhalese, and there was not so much of a requirement of learning Sinhalese because somehow we thought that if there is no market, people will not get employment. However, now the newer market is coming because of the new dynamics of the market. In the new dynamics of market, we have issues related to globalization versus localization. We have a globalized market, and that market needs localization of products. If we need to sell, let's say, our books, because I'm writing, or we all are engaged in writing books, so I'm talking of books, but the same can be applicable to our spices also, the way we sell. So our spice producing companies, when we have a lot of productions of different brands of spices, how do you sell that in a country which is close to ours, but slightly different from our ways of eating? Sri Lankan food is very close to ours, but yet it is slightly different. So you see, we have to understand these kind of products, and we have to find out the intercultural situations in which these two societies operate. And the intercultural situations might talk of the food, they might talk of clothing, they might talk of how you prepare the paratexts for the books that we produced. It is a lot in the paratext that the books might be attracting for them. Not only the stories might be there, the content is very important. But this we have to understand that there has to have an understanding of products for India as well as for countries nearby India, and not so nearby, but far beyond the societies. We may have to think of the African continents. We may have to think of the countries southeast of Asia. So we have to work upon these new language pairs with an understanding that it is not simply translation, but it is trans-socialization. The moment we talk of translations, actually it is more of trans-socialization with which we are dealing. And that is a very important aspect on which we need to understand in the context of language pairs. We have to develop new tools for understanding these kind of contrastive study also of any relevant pair that we may talk about. For example, I can see here that we are talking of defense technologies. Our defense forces continuously interact with many societies east to India. For example, Indonesia, Thailand, Maldives, and all that, but we don't have sufficient data available on these languages, nor we have been able to work on these languages in comparison to our own languages. So this kind of contrastive analysis is very much a requirement of our times as well as of future, because the future growth engines will be in these societies. We know that Asian societies are becoming more and more very important in terms of the global exchange of money and power. So in this context, we need to work on more and more of the contrastive study of relevant language pairs. And from the East countries, the Far East countries, we still don't have any study undertaken between Indian languages and, let's say, Khmer language. Of course, both of them come from the Austroasiatic group. Khmer is an Austroasiatic language. In India also, we have Austroasiatic language, Munda, Mundari, and all these languages we speak. But there is no clear understanding of the relationship that we have, the kind of contrastive tools that we require. We have no such study undertaken, and we need to undertake these studies not only for commercial purposes, but also for the lost business opportunities. And that is one part, plus the kind of cultural connect that we have and the intellectual tools that we need for all that. We need to work more and more on that. For example, translation itself can get a lot of new theorization if we look at the Indian text being translated towards the Eastern societies. What were their methods of translation? How they translated? All these aspects have not been studied. How a Buddhist mantra is translated in Cambodia, how it has gone from here to Tibet to China and further to Korea to Japan and all that. This aspect is completely missing. So we need to take up these new aspects, and we need to understand all these in the context of Eastern perspectives, and we being part of Eastern perspective, as well as the countries further east to us, further Orient, far Orient. All that language pairs we need to understand, and we need to produce in that context new kinds of contextualized pedagogical materials. Even if, let's say, we are teaching French or German or any European language, we need to create such materials which are relevant for our people who do not know English, because that's the requirement. Everyone will not be so conversed with the English in our context. Plus, English is also being more and more Indianized. What do we mean by more and more Indianized? This Indianization of English simply means that we are imbibing the characters of the Indian language, the features, the syntactic, the linguistic features of the Indian language into English. So all that aspect have to be thoroughly worked upon in terms of language pairs, and a direct intercultural contrastive studies need to be undertaken for the future growth. And here, the language analytics as well as the computational aspects of language and the natural language programming, all of us, all these experts, we have to collaborate. Work is going on, but until now the work is confined to only a few languages, let's say for Sanskrit, etc. But we need more and more data, and we need to look towards the Eastern perspectives and work more vigorously on these areas. That is the future growth for us. And the purpose will always be to create more and more understanding of world cultures and create tools that might help us overcome the differences that arise due to the differences in cultures, the new cultures that we meet. And English is not sufficient for that, because there is a lot of commonality and there is a lot of requirement of understanding that commonality in entire Eastern perspectives when we deal with these Eastern or Oriental societies at a larger level in various aspects, intellectually, commercially, in terms of power dynamics, etc., etc. So with this, I stop today, and all questions, etc., any remarks are welcome.
Thank you so much, sir, for your enlightening speech and reflecting on status of languages, variety of languages, and foreign languages. I'm sure our students will definitely get benefited from it. Thank you so much, sir, for your speech.
So is that fine? Is it fine? Should I leave? My session is over.
Any question from the audience? Any question from the audience? No questions? Okay, sir. Thank you so much, sir.
Thank you. Thank you.
Hello. Reshma ma'am, are you there? Reshma ma'am, are you there?
Yes, I'm here only.
Okay, ma'am. Now it's your turn, ma'am. Your keynote speech.
Can you hear me?
Yes, ma'am. Yes, ma'am. Now, ma'am. Yeah. Our second keynote speaker is Dr. Reshma Rastogi, ma'am. Dr. Reshma Rastogi, ma'am, received the PhD degree in machine learning from IIT Delhi. She is currently an associate professor with the Department of Computer Science, South Asian University, New Delhi. She has published over 42 papers in referred international journals and over 16 papers in referred international conferences in these areas. Her recent work on TWSVM has been cited over 1250 times and has been a subject of reviewed articles in multiple highly reputed journals. Ma'am, I invite you to deliver your keynote speech.
Screen visible? Is my screen visible?
Yes, ma'am.
Okay. So today I'm going to talk about large-scale learning using machine learning. I'm thankful to the organizers for inviting me on this platform. So I hope several people, several researchers, several keynote speakers have already been gone through the machine learning area. So I'm just trying to tell in this 10 minutes of the keynote that where actually we land up when we have large scale data. So the situations of, so we know that, the learning starts itself from a very young age. So if you see a 6 months old child, if you give the person, the child, the small instrument to be played, the child will be able to learn itself even after several trials, and maybe after 12 months of learning, the child itself is able to learn everything about the instrument. So the data is everywhere, and it's the how we use it and what sort of data is there. It's really an important challenge when we use any kind of machine learning algorithm. Like, for example, in the recommendation system also, the data is huge. Now everybody using online, everything is being there, so the data is huge, it's massive. So for example, if you talk about the automated car also, so data is used. So for example, if you see in this slide, what we can see. So there are several the buildings, the pedestrian, the lights, the vehicle. When it comes to analyze, like for example, if I talk about in this in this video itself, so the people are walking on pedestrian. So and it's very so if you want to identify these pedestrian, then it's a computer vision algorithm. Now if you pass this data to a neural network or to an advanced, deep neural network, then the amount of data which is fetched inside the learning algorithm itself is huge. So that means where do we end up? We end up learning these algorithms with huge data, and like for deep learning model, it's the data only from which we learn, because we generally don't generate features. The features are being generated if you pass on a computer vision algorithm to a machine learning algorithm. But when we are dealing with deep neural networks, we just pass on the images. So imagine the kind of data we have to fetch in so that it can be generalizable. So because when we send an image to any machine learning algorithm, we generally fetch in the values, and from the values, whether you use CNN models, whether you use high-end architectures, neural network architectures, everything is being studied in terms of numbers, and how these are being processed again is a kind of a black box which is not known to us. For example, if you see this Facebook is now using deep learning models to identify everything which is hidden in a particular image. So for example, if it is related to the face, and so every minute details has been identified. So whether it is content based image retrieval, where from the images you need to build up a model so that with a query image you can retrieve all these sort of images. So the point is, in any sort of algorithm, whether you go through machine learning or whether you go through deep neural architecture, the idea is that on one hand you are sending enormous data to the deep neural networks. On the other hand, if you are choose to select machine learning algorithm, then we have to identify the relevant computer vision models when we are dealing with images, and if we are dealing with a time series data, then we have to identify the proper selection of algorithms which can generate the set of features which can be passed on to the machine learning algorithm. So because see, when as a human, I took an example of a kid who is generalizing or learning through its own experience. So our human brain is consisting of so many nerves, and each and everything is being interpreted in terms of some kind of neurons, and finally learning is being done using several by taking several combinations of the nerves present in the human brain. The same replica, so it shorts the so if you study the architecture, it's basically there's an axon and there's a synapse, and so if it only uh, so if you compare this with the neural network architecture, so the idea is that the same replica has been done in the neural network, where you if it, until unless a threshold is being reached, it will not shoot, right? So it will not predict it. So the same architecture has been taken to the neural networks by taking the motivation from brain, and to starting with the simple architecture of perceptron model. Now people have started over a multi-layer perceptron, and moving forward from multi-layer perceptron to deep neural networks. So the idea is that everywhere, either you give the enormous amount of data to the system so that it learns automatically, because if you see here, it's kind of a learning which takes a linear combinations of the features when you pass on to the system, and it if you observe here, it's a kind of a non-linear representation of the initial set of features which is being learned by the neural network architecture. So now the is that whether we should go for a machine learning model or to in in the overall summarization of what I would like to highlight over here is that depending upon the problem in hand, for example, when we talk about quantum machine learning, right? So now quantum machine learning is nothing but the amalgamation of quantum computing with machine learning algorithm. So there itself, the idea is that you process the data into the quantum states and pass it to a machine learning algorithm. Now, so machine learning algorithm needs a representation of a data in such a manner that it understands it. So, like in the case of images, we need to use computer vision to extract the features so that we can pass on to the machine learning algorithm. No matter, for the data is small or large, machine learning will be able to handle it because you have passed on sufficient amount of you have gone with a sufficient amount of feature representation. So there's a representation learning which is there in machine learning area. Compared to that, we have deep learning architecture where enough amount of data have been sent, so it will learn automatically. But again, it's a black box. You don't know which features have been learned. So if you want to analyze that which features are important for you, which features are not important for you, then you are stuck. You don't know the answer for that. So these are two different architectures. Going forward, now everybody is talking about quantum machine learning. So there also we need to draw a line where we need to say that where we should use quantum machine learning, where we should use machine learning, where we should use the deep learning architecture. So if someone says that since I need to see how effectively the quantum machine learnings are algorithms are, then just passing on the data itself in the quantumized domain doesn't serve the purpose. You need to understand, you need to appreciate that the problems which are NP hard, right? So those problems which are not solvable, and you do some approximation so that it can be solvable either using deep neural networks or using machine learning models, that can be only solved through quantum, because that gives an exposure to explore different possible combinations of the search space. So it gives you enlarged search space, which is compromised when we are using classical machine learning. So the only the only takeaway from my today's talk is that before even jumping into any area or before even selecting it to any architecture, we need to understand that what is the requirement. So if the data set is large, so we say large data set. So when we talk about DNA data set is also large, but it's large in sense of its features. The size of features is in now thousands, and but the number of samples are very less. So if you pass on this data to a deep neural architecture, it will fail because the data set, it needs data. It doesn't need features, it needs data, because feature engineering is anyway being done by the neural network architecture. On the other hand, if you pass on this DNA data with small number of samples, with 30 and 40 samples, but still with large number of features to machine learning algorithm, it will definitely do. Now, there is no role of quantum machine learning over here, because anyway, this problem is solvable in a classical domain. So the only takeaway would be to first decide upon the problem in hand, and based on that, you select an architecture who to select. So although there are several models available in literature, CNNs are very common, and several extensions of that LSTM models have been used in the text classification also. And in the recommendation system, several combinations have been used. But then again, we need to ask ourselves that what is our scenario, what is the data, and how should we process it using the several architectures available in domain. Thank you so much. Any questions?
Thank you so much, ma'am, for insightful talk on machine learning, deep learning, and neural networks. Thank you so much, ma'am. Now we have our next key speaker, Dr. Rajiv Ghosh. Sir has already joined. Welcome you, sir. Dr. Rajiv Ghosh is an assistant professor at NIT Patna. He has been listed in world's top 2% scientist list by Stanford University and Elsevier in 2024 and 2025 in the area of artificial intelligence and image processing. His working areas include pattern recognition, document image analysis and recognition, computer vision, machine learning, video surveillance, and medical diagnosis areas. Sir, I invite you to deliver your keynote speech.
Okay, is my slide visible?
Yes, sir. Yes, sir.
Okay, am I audible properly?
Yes, sir.
Okay. So good morning to all of you, all the
Yes,
faculty
sir.
members of MIT Patna, as well as all the audiences, participants. And thank you for inviting me to give a keynote speech in your conference. So today I will talk on this topic. I think it is visible, the title of my talk, Diagnosis of Neurological Disorder, New Frontier in Online Handwriting Recognition. That means actually using our online handwriting or by putting different online handwriting, different tasks using online handwriting mode. Online handwritten actually collected using some digitizing tablet like Wacom tablet is available. So various types of handwriting from different persons, and by collecting the handwriting we do lots of actually pattern recognition related works like character recognition, word recognition, paragraph recognition, all these things. So these are actually some known works in online handwriting recognition, and these works are actually going on from last several years, we can say 10-15 years. But now the new frontier is there. Recently, these things actually have been started, these type of researches, that by analyzing online handwriting, by collecting the handwritten tasks, different types of tasks, it can be drawing of different spiral, drawing of different diagrams, or it can be collection of normal characters or words in different scripts, Latin script, Devanagari script. So whatever be, that means by collecting the online handwriting using the digitizing tablet like Wacom tablet available, we can also diagnose different neurological disorders. So this is the new frontier in online handwriting recognition. Apart from the normal conventional character recognition, word recognition, or writer identification that is used in criminal investigation. Apart from those things are going on from last 10-15 years. So this is a new one. So today I am going to deliver on this several neurological disorders are there. I think all of you know, like Parkinson disease, one neurological disorder, Alzheimer's disease, epilepsy, schizophrenia, various types of neurological disorders are there. Today, actually, the thing that I would like to discuss that is related to Parkinson disease diagnosis. So, Parkinson disease diagnosis can also be done by analyzing online handwriting. That means those who are suffering from Parkinson and those who are normal, not suffering from Parkinson, if we collect their online handwriting, it may be different diagrams, it may be different characters, then obviously we'll see significant amount of discrimination between the characters written by the normal person, those who are not suffering from Parkinson, as well as those who are suffering from Parkinson, because we know that Parkinson disease is one of the most common neurodegenerative disease, is a growing health problem. It is mainly characterized by motor symptoms including these bradykinesia, akinesia, and tremor. Currently, there is no cure, but an early diagnosis of PD could be crucial for the medical treatment and for evaluating the effectiveness of new drug. Okay, so is it visible? The video is available or not?
Yes, sir, it is visible.
Yes, sir. It's visible.
No, my is coming there.
Yes, sir.
Okay, so develop a Parkinson is classification system by analyzing online handwriting. That is the objective actually of this work. So as I have told, handwriting activity entailing cognitive, kinesthetic, and perceptual motor components, the changes in which can be promising biomarker for the diagnosis of PD. That means when we put our handwriting, actually different motors actually in our brain. Actually, they work for different types of handwriting, for character for when we are putting some characters or when we are putting some diagrams, and it is also cognitive work. So and Parkinson actually disease is one type of disease where that is in our brain there is one area or region that is called actually STN region. So in that, from that region, some neurons are there. They generate the dopamine. So dopamine is one chemical, and if the generation of dopamine gradually reduces, then actually Parkinson disease occurs. And these dopamines are generated by those neurons present in that area, STN area. So whenever actually we are collecting different handwriting, different cognitive as well as perceptual motor components work in our brain, and accordingly the electrical signals that are generated from our brain, that also vary based on different types of works. Not only that, electrical signals will vary between the two different persons suffering from Parkinson and the normal one. So those things actually are reflected in the handwriting. And we know actually those who are suffering from Parkinson, their hands may shiver. They cannot write properly when they are writing, when they are holding the pen, when they are writing something like the normal person. So they may take much more time to write anything. And accordingly, the different features that we actually extract from the handwriting, they may vary. Okay. So that I told, online handwriting is collected using digitizing tablet, basic strokes from the building blocks of an online handwritten text. So this is actually one example that online handwritten tasks that have been actually used to differentiate between Parkinson and normal persons. Here you can see first diagram is a spiral, and in the second part you can see different characters are there, where actually unigram is there, bigram. Unigram means only single character, bigram means two characters. In this way, then multiple characters are there, words are there. So these sort of things, these sort of samples have been given to those persons, those who are suffering from Parkinson as well as those who are normal, to write it on the digitizing tablet. So this digitizing tablet that I was telling, one Wacom tablet is available. Using that, actually we can write on that digitizing tablet, and that can be collected to my computer by connecting it with some USB device. So this sort of handwritten actually samples have been given. Now this is the distribution of age-wise PD and non-PD status. That means from the samples from the persons, the data have been collected. They are age-wise distribution, PD and non-PD. And these two samples are handwritten tasks, Archimedean spiral drawn by one non-PD subject and Archimedean spiral drawn by one PD subject. So from this, it can be clear that I was telling, if any person suffering from disease, all of you know, there will be different problems in their movement, hand movement, leg movement. So when they walk also, they cannot walk normally. So another type of that is method is there to diagnose Parkinson disease, that is by analyzing the gait recognition or walking activity. So that is another work. This thing we have done is by analyzing the online handwriting. So their hand also actually cannot work, cannot move normally like the normal person. So that I was telling, that if any person suffering from PD, they put any diagram or any handwritten characters, whatever be, their hand generally shivers and they cannot write normally. So they will take much more time to complete the task. So you can see the second one B, that is Archimedean spiral drawn by one PD subject. So you can see actually there are lots of distortions in that diagram in comparison to the first one A, that has been drawn by one non-PD subject, normal person. So clearly from these samples of drawn by one PD people and normal people, we can clearly discriminate that which person is suffering from PD and which person is normal. So this discrimination will be known by the machine learning classifier, or will be predicted by the machine learning classifier by extracting those appropriate, relevant, discriminating features. So these are the features actually have been extracted: trajectory speed along x-axis, trajectory speed along y-axis. Okay, so these are actually two samples that I am showing. But as I told here, as I mentioned, apart from the Archimedean spiral drawing, you can see these type of samples have been given in front of the those persons, those who are suffering from Parkinson as well as those are normal. So apart from Archimedean spiral, different characters and words also have been asked to write by them. Okay. So these features have been extracted. These are relevant and your discriminating features, which will be able to discriminate between the handwritten tasks performed by one normal person as well as by one person suffering from PD. So these are the features: trajectory speed along x-axis, trajectory speed along y-axis. Okay, so actually in the digitizing tablet, there is one pen that is called sensor pen. That diagram is not there with me, but I'm telling you, one pen is there looking like our normal pen, but that is actually looking like the normal pen, but it doesn't work like a normal pen. There is one sensor is there in the pen. So that pen, when we are actually bringing to the close proximity of the tab, then actually it can actually detect, the tab can detect that something we are going to write. But if it is very far from that pen, if it is very far from the tab, then it cannot actually detect. And then when we are touching the surface of the tab, then whatever actually we are writing, those will be actually collected by the tab and it will be reflected on my computer if I connect the tab to the computer with the USB device. So whenever actually a person holding a pen within a certain distance from the tab, then the trajectory speed, actually trajectory speed along x-axis, along y-axis, and then pen down acceleration, pen down, pen up velocity. So those things actually, pen down means actually when you are touching the surface, but trajectory speed, that means when actually it is written on the surface, then what is the speed of writing along x-axis, along y-axis. Okay, then pen down acceleration. Acceleration is that feature where actually we are holding the pen but we have not touched the surface. It is within a specific threshold of distance. Then the acceleration along x-axis and along y-axis will be extracted, can be extracted, those features by your program, because as well as by the tab also it can sense it. That normal person actually, if they are holding the pen and if they are going to write, but they have not touched the surface, but it is within a certain distance, certain threshold, then their acceleration will be faster, obviously, in comparison to the person suffering from PD. So their acceleration will be a little bit lesser because their hand movement is actually always takes much more time. Leg movement also, here leg movement is not required. It is for another work. But here hand movement is required. Hand movement is generally slower of the person suffering from PD. So their acceleration will be lesser. So these two features, pen down acceleration and pen down acceleration along x-axis and y-axis, this can be actually captured when we are not touching the surface, but it is within the certain distance from the tab. Then, but pen down velocity along x-axis, along y-axis, these two features will be extracted when we are touching the surface. Trajectory speed along x-axis, trajectory speed along y-axis, these two will be extracted when we are touching the surface. That means we are writing something, some character or any drawing, any spiral, archimedean spiral we are drawing. So trajectory speed, trajectory means actually their stroke. A stroke is what? Stroke is actually the points that are collected between one pen up, between one pen down and the next pen up. That means when you are touching the surface for the first time, that is pen down, and from that point to next pen up, when you are leaving the surface, that pen, when it is leaving the surface, that is called pen up. So from the one pen down to next pen up, within this duration, the points that we are plotting on the surface of the tab, that is called, sorry, 1 minute. That is called actually the stroke. Okay, so that is called stroke. So stroke actually, we are writing means actually we are writing something on the on my tab. It can be any character or it can be any spiral. So that stroke is called trajectory. So trajectory speed along x-axis, trajectory speed along y-axis means when you are writing a stroke, in how much speed we are writing on the surface. So obviously it will also vary. If a normal person is writing, they can write faster, and if a person suffering from PD, if they are writing, their writing will be very slow. So from these two features also we can discriminate that particular sample of handwritten samples, who has written, whether one normal person has written or whether any person suffering from PD has written. So these features actually are discriminating features. So these features have been extracted. Similarly, pen up velocity, pen up acceleration. Pen up means when you are leaving actually, when you are lifting up the pen from the surface, that is called pen up. So that time what is the velocity? That means it is not touching the surface, but we have actually lifted up the pen. We will write another stroke, or we will write another character. So we are lifting up the pen like we normally do in paper when we are writing using a pen. We are writing something, then we are lifting a pen, then we are writing another character. So that is called pen up. So that time what is the velocity along x-axis and along y-axis? Okay. So pen up velocity along x-axis here, pen up velocity along y-axis here. So that will also vary. If it is normal person, their actually pen up velocity will be faster, obviously. And if somebody suffering from Parkinson disease, their pen up velocity will be slower. So these are discriminating features. From these features, we can differentiate. We can discriminate easily the handwritten samples provided by whom? By normal person or Parkinson disease. Okay. So these are the features. Similarly, other features, these are the equations of these features, how it has been calculated. I am not going into details. Totally mathematical equations are there to actually extract these different features. And then finally, 4 different classifiers, machine learning classifiers have been used here to actually predict or to discriminate or we can say to classify between a normal person and the PD person. So SVM classifier has been used, support vector machine, AdaBoost, BRF, that is random forest, and RNN, recurrent neural network, has been used in this way and in this work. And RNN's 2 versions have been used, 2 variants have been used, LSTM as well as BLSTM, long short-term memory and bidirectional long short-term memory. And different common popular dimensional reduction techniques have also been used, like PCA, LDA, and factor analysis to reduce the dimension of the feature vectors that were generated after extracting the feature values. Because it has been seen, if we reduce the dimensionality of the feature vectors and if we are not reducing the dimensionality of the original feature vectors after extracting the features, accuracy varies actually. So we have checked actually by applying dimensional reduction techniques also. And these are the hyperparameters, and these are the results actually of this work that we have got. So task 5 actually, task 5 is which one? Task 5 is this one that earlier I showed. These are the actual 8 different tasks. So these tasks have been actually written on one paper, on one normal page, and that have been given to the each and every persons from whom we have samples, and they have been asked to write these things. So task 5 means this one. You can see one word is there written in Latin script, Latin alphabet. So this task 5 has provided the best accuracy, task 5, and it has provided 100% accuracy for when we have applied LSTM variant of INN classifier and BLSTM variant of INN classifier. And for BRF and SBM, it has given a little bit lesser. So LSTM and BLSTM have provided maximum accuracy, because LSTM and BLSTM were invented for this purpose, mainly to capture the temporal dependencies. Okay, temporal dependencies of any sequence. That means for temporal sequential data, LSTM and BLSTM were invented. And our online handwriting is always a temporal sequential data, because online handwriting, as I have told, when pen is touching the surface from that point, and when you are lifting the pen, so in this duration, lots of points are plotted, and all these points are plotted in different timestamp. Because very first point will be plotted at timestamp t, then next point will be plotted at timestamp t+1 in this way. So all these are temporal points. So basically it is a temporal sequence. So for temporals, any temporal sequential of data, temporal sequential type of data, or temporal mapping of any sequence, LSTM, BLSTM, basically for this purpose were proposed, were invented earlier. And it is the best actually, LSTM or BLSTM, if we apply for temporal sequential data. And if the sequence is too long, very long, then actually LSTM sometimes fails. And that's why in 2017, transformer neural network was invented. And transformer neural network in NLP we use if the temporal sequence is too long, then LSTM may not actually give satisfying results sometime. So that's why. But if it is not too long, LSTM, BLSTM were invented for that purpose, for temporal sequential data, and it is the best. So that's why naturally we can see when you are applying SVM or BRF, those cannot map, those classifiers cannot map temporal sequential data. But LSTM, BLSTM, since they can map, so they have provided the maximum accuracy, best accuracy, and it is actually expected also, and it is natural also, that LSTM and BLSTM in any online handwriting recognition, they will provide the best accuracy in comparison to other classifiers, and they have done it and then they have provided it. It was expected. Okay, and accordingly it came. So and this is actually overall result, and this is actually the result by varying the hyperparameters of different hyperparameters of LSTM, BLSTM. And like here we are seeing that task 5 is providing best accuracy 100% for LSTM, BLSTM. Now that 100% has been provided, 100% classification accuracy has been provided for which combination of hyperparameter values, and that is hidden layer when you have taken 3 in the LSTM, 40 epochs when you have actually used to train the LSTM, and number of blocks that you have taken in 3 different layers, 20, 20 and 10. So for that combination, and batch size 5, for that combination, this 100% was provided. And lots of other combinations are being shown in this table. They could not provide 100% classification accuracy, little bit lesser. Okay, so it is actually detailed actually results, that is applying LSTM, BLSTM, when for different combinations of different hyperparameter values it has been tested. So this is the thing. And this is actually by applying the different dimensional reduction techniques that I was telling. Without applying dimensional reduction techniques also it has been done, and this is with applying dimensional reduction techniques. When you have applied the dimensional reduction techniques, okay, using PCA, we have got this 100% result. And if we are not applying dimensional reduction techniques, we got the lesser one. So this is the thing, and this is ROC curve. That is another metric that we use to measure the performance of any classifier. So ROC curve actually, this is ROC curve against the BLSTM variant of the iron classifier, that how it is performing, how well it is performing. So this is ROC curve, and from this actual ROC curve we can see that it is performing well, because it is gradually going towards the true positive value 1, as we are actually increasing the false positive rate. So this is actually thing, and this actually work has been done by us, and we have got one patent also on this. Already patent has been granted in the last year. So this much actually, this is my talk, this much for today's talk. Now, if you have any questions, you can ask me.
Thank you so much, sir, for your insightful presentation on neurological disorder. Any questions from the audience? Any question from the audience? Thank you so much, sir, for your insightful talk.
Okay, thank you. Okay, thank you. So
Now,
shall I,
moving
can I
to
leave?
our next sections. Yes, sir.
Okay, thank you. Thank you
Now,
very
moving
much
to our
for
next
inviting
section,
me,
that
and
is
thank you once
presentation
again.
section.
Okay.
Thank you so much. Thank you so much, sir. Now, moving to our next section, that is presentation section. So, all the presenters are requested to be ready with their PPTs. Our first presenter is Dr. Ramesh Kumar. He will be presenting a paper titled Cultural Adaptation in Machine Translation, Challenges and Solutions. I invite Dr. Ramesh Kumar.
A very good morning to everyone. The title of my research paper is Cultural Adaptation in Machine Translation, Challenges and Solutions. This paper tries to explore the multifaceted challenges in of cultural translation in the machine translation systems. The paper delineates the specific challenges, the shortcomings of the current approaches, and the proposed solution in this regard. Move to the first slide. Yeah. Before moving ahead, let's what we understand by the term cultural adaptation. let's think about that. The cultural adaptation is the process of modifying a cultural element to make it understandable, acceptable, and relevant for a target language. It involves more than substituting the words. Rather, it requires a holistic understanding of socio-cultural context, social norms, and the value systems of both the source and target languages. So, needless to say that machine translation has become an indispensable tool in our increasingly globalized world, which breaks down the language barriers in several domains of the knowledge, any sphere of the knowledge. The advent of neural machine translation, NMT, with its ability to model complex linguistic patterns, has led to translations that seem fluent and syntactically and semantically accurate or fluent. However, fluency doesn't equate with the competence. So, a translation can be grammatically correct, but it can be culturally absurd, nonsensical, or ungraspable. So now move to the next slide. Now let's talk about the specific challenges of cultural adaptation in machine translation. The specific challenges of the cultural adaptation in machine translations diverse and multifaceted. Let me highlight some of them which we can consider as the most significant obstacles in this regard. The first is culturally specific concepts. Culturally specific concepts are the phrases or terms that denote objects, concepts, or practices unique to the specific culture and have no direct equivalent in the target culture. For example, as you can see on the slide, the cultural the Hindi terms like kharao, janeo, and another regional slangs, abusive terms like harami, kamina, lucha. And if you are, I hope you all are familiar with the regional literature of Fansbar Atredo. You must have read the. You must have been familiar with the terms like mujhosa, dadija, khoki, etc. These are the slangs which are abundant in the literature of Parishvara Renu and other like Nagarjuna and so many authors, regional authors. So these are the cultural specific terms, expressions. The next category is humor, sarcasm, and irony. These are highly culture dependent terms or expressions which rely on shared knowledge and the subtle linguistic cues. These are connected to the specific socio-cultural aspects of any regional regional lifestyle or regional context. So, for example, Hindi sayings "कौवा चला हंस की चाल" और "आगे नाक न पीछे पड़." These are the sarcastic or ironical expressions which we can't translate literally in any target language, as it would be unacceptable and ungraspable, and it might be even it can go to the extent of absurd. So we can't translate these things literally as the machine translation models do that. And we can also include the speech acts like in the indirect request. A phrase like "Could you pass the salt?" is not a question about the ability. Rather, it's a polite request, indirect request. So we can't, if we translate it literally in any language, it can distort the intention of the speaker, the motive of the speaker. Move to the next slide. So now let's specify the solutions that we can propose in this context. Let me highlight some of them which we can consider the most significant. The first is data-centric solutions. We have culturally annotated corpora. We can create training data sets where cultural elements are explicitly tagged. This allows models to learn to identify and handle these elements in the effective way. The next one is data augmentation. We can generate synthetic data that presents the same meaning in different cultural contexts. For example, creating parallel sentences where a reference to a local pub is adapted to a local tea house for a Chinese context. The next one is curation of culturally diverse data. We can actively seek out and incorporate high quality text from the different cultural sources, including literature, local news, and official documents from diverse regions. The next section is algorithmic and architectural innovations. Under this, we can have context-aware neural machine translations. We can develop models that can process much larger context beyond the sentence level. We have to move beyond the sentence level. We have to identify the overall discourse of the specific term and expression in that context. The next one is the next section is evaluation and interactive systems. Move to the next slide, please. Evaluation and interactive system. Under this, we can move beyond metrics like BLEU, which measures n-gram overlap with a reference translation, towards metrics that can assess culturally adequacy, fluency, and pragmatic appropriateness. And also, we can acknowledge that full automation may yet not be feasible for high-stake content. Machine translation can serve as a powerful first draft with human post editors specializing in localizing, providing the final cultural polish. So these are the steps, these are the proposed solutions that we can adhere to in order to meet the challenges. In closing, I would like to say that cultural adaptation represents one of the most challenging and complex obstacles which is faced by the field of machine translation. So in order to meet these challenges, these specific and significant challenges, we can a synergistic approach is necessary, which would combine sophisticated data curation, algorithmic innovations that incorporate external knowledge, and new evaluation paradigms that prioritize cultural adequacy. The development of interactive and controllable systems will empower users to guide the translation process. We have to move beyond statistical models to incorporate the deeper understanding of the deeper understanding of the you know the cultural elements of the concerned text. So we have to admit that the future of machine translation doesn't lie in creating a single omnipotent system, but in building flexible, transparent, and collaborative tools that work in partnership with human cultural understanding. By embracing this challenge, we can move closer to a world where technology not only translates our words but also helps bridge our cultures. That's all. Thank you
Okay,
so much.
so
You all.
one query from my side.
Thank you so much.
Thank you, Dr. Ramesh, for your wonderful presentation on translation study. Any questions? Any questions from the session chair or audience?
Yeah, one question from my
You
side.
may ask.
So apart from the synergic approach that been proposed, there is any other possibility that can be solved culturally specific race based problems?
Can you repeat the question, please?
So as you mentioned that the synergistic based approach that have been used to solve the problem. Apart from this, any other alternative solution that you found during your literature?
Please repeat once again.
Your voice is not clear.
Am I audible? No?
Yes, yes.
Yes.
So my question is that as you mentioned the synergetic approach in your paper, that is one of the possible solution for the problem that you presented. So any other possible solution that you found in your literature that can solve the problem?
Yeah, the thing is that apart from taking help the AI systems uh, for machine translation, we have to train and skill the human expertise also in order to deal in the things in holistic and comprehensive way. We have to put the onus equally on the AI systems and as well as human expertise. That is my
Okay.
proposition.
Okay. Thank you. Thank you.
Any other question?
No
Thank
question
you.
from my side.
Thank you so much, sir. Our next presenter is Bantilan, Mukhim, and Sufadas. They will be presenting a paper titled Understanding Sentiments and Emotions in Classic Computational Approach Using Wallon's Arousal Dominance Codes. All presenters will get maximum 5 minutes for presentation and 2 minutes for question answer discussion. Bantilan, over to you.
All right. Thank you, sir.
Please we
Let
stick
me share
with
my screen, sir.
time deadline. Please we stick with time deadline.
Sure, sir. Good morning, everyone. I'm Bantalam Mukim, and now I'm going to present a paper titled Understanding Sentiment and Emotion in CASI, a computational approach using valence, arousal, and dominance. So emotion analysis and sentiment analysis is a task of finding or detecting people's emotion, likes, dislikes, or the negativity or positivity of the text. And to do this, I have choose this approach, which is the computational approach to using the valence, arousal, and dominance to determine the sentiments and the emotion of the text. So every word has three affective dimensions, which we call the valence, arousal, and dominance. The arousal The valence measure the pleasantness or the unpleasantness of a word, that is whether it is a positive or a negative word. And the arousal measure the intensity of the emotion, whether it's high or low, whether it is exciting or calm. And the dominance measure the control or the power of the emotion or the sentiment. And in English, we have a predefined lexicon, which we call the NRC VAD lexicons, which contains a human rating of 55,000 English words, and each word has the associated score for the valence, arousal, and dominance. And the other lexicon, which is used for emotion, is the NRC emotion lexicon, which contains a list of English words and their associated um, eight emotion. And in this work, I have translated the English VAD and the English Emolex into Kasi to create a Kasi VAD lexicon and a Kasi Emolex. And out of the 55,000 English words, I'm able to translate only 18,000 of it into Kasi word. And the emotion is determined by calculating the emotion and the sentiments is determined by calculating the VAD score of the text. And to improve the accuracy, I've also implemented a checker, which will correct the spelling mistake in the text before applying the emotion detection and the sentiment syntax using the CASI VAD and the CASI Emolex lexicon. And this is the methodology which I followed. So the NRC VAD lexicon will be translated into CASI to obtain a CASI VAD lexicon. And then the comment text will be corrected for the spelling mistake using a spell checker, and pre-processing will be applied. And finally, the sentiment and emotion will be applied on the text to obtain the sentiment level and the emotion level.
What are the major sentiment that have covered? Go back the previous one. Go back the previous one. Yes, the sentiment. How the major sentiment that is covered.
The sentiment is negative and positive sentiments, sir. And
Hmm.
and for the emotion, there are 8 class of emotion which I've covered here, which is anger, fear, anticipation, trust, surprise, sadness, joy, and disgust.
Okay, continue.
Shall I continue, sir? Okay, thank you, sir. Thank you, sir. So for the spell checker, I've used the Levenstein distance to predict the closest word to of the misspelled word, and also to further improve the accuracy. I've also implemented a trigram model to get a contextualized spell checker to correct the misspelled words on the text. And this is the algorithm of a spell checker. It has 3 main steps: step 1, step 2, and step 3. In step 1, the text will be tokenized. And then after in step 2, each token will be compared against the dictionary. And if the word is not present in dictionary, then the Levenstein distance is applied to predict or to get the closest word to the misspelled word. Like for example here, let's say I have this word KM, which is a misspelled word, and the threshold of the distance here is 1, and the possible candidate for this misspelled word is KA, which we got it by replacing M with A, and then KM, which we got by inserting an A in this misspelled word. And then as I've said, after we obtain the list of candidate correct word, then a trigram model is used to predict the most correct word. And the trigram model uses the probability to predict whether a word appear given 2 other words. And this is the formula here, PWI given WI W2, where this word WI appears after the word WI minus 2 and WI minus 1. So this is the example. And after we have calculated the score, then the text, the word with the maximum score will be selected. And for the sentiment analysis and emotion detection, each word in text will be analyzed, and the corresponding valent arousal and dominant score will be calculated. And then over here, I've set a threshold of 0.6 for violence. If the score is violence goes 0.6, it is positive. It is less than 4.4, then it is negative. Otherwise, it is neutral. And for the emotion, I've implemented the Emolex lexicon along with the VAD. And here, the number of emotion words in the text is counted, and then the VAD score is used to get the intensity of the emotion. And in conclusion, by using like a lexicon approach, we avoid traditional problem of needing a big problem of annotated data. And adding a spell checker and correction features make the feature more reliable when working with noisy or content. And the limitation feature scope, out of the 55,000 English word which is in the original NRC VAD lexicon, I'm able to obtain only 80,000 of the Khasi word for it. And then the lexicon base does not take into account the sarcasm or figurative language. And the future scope, since there's a limited work in this field sentiment analysis and emotion for Cassie text, and there's a similar scope for improvement. Okay, thank you, sir.
So one question from my side. What is the difference between a lexicon-based and sentiment analysis and machine learning-based sentiment analysis?
In machine learning based, we need to have an annotated data, a labeled data which is labeled with emotion and sentiment, and then we can use this data. You can use machine learning to train or to learn from this data, sir.
And you covered both aspect in your this research work.
Pardon, sir?
In your research work, you covered both lexicon-based as well as machine learning-based.
No, only lexicon based, sir. Only lexicon based, sir.
So what happened if the machine learning-based is occurred?
If in machine learning, so we need to have a label data, sir.
Okay, so the label data is required for that purpose.
Yes, sir.
Okay, thank you.
Okay, thank you, sir. Thank you, sir. Thank you, sir.
The audio is not coming. You are not audible.
And it's my pleasure to welcome you all to this session on how Sanskrit helps in making AI agents, a comprehensive review. Yeah. In this presentation, we will see how ancient Sanskrit linguistic and modern artificial intelligence can enhance the machine translation. This is the abstract of the research paper. The Sanskrit systematic grammar, morphology, and linguistic precision make it ideal for AI and NLP. When we talk about Sanskrit systematic grammar, we will talk about a book, Ashtadhyay, written by Maharishi Panini, in which all the rules of the Sanskrit grammar are well organized. And what about morphology? What about morphology? Morphology means the study of the structure of word and formation of the word. And the linguistic precision means choosing the right word, right grammar, and right structure so that the message cannot be misunderstood. Let me proceed. Before proceeding, I would like to give an example to understand what you mean by precise and not precise. When we are saying a sentence that he finished the work soon, this sentence comes under not precise. But when we are saying he finished the work in 10 minutes, this sentence comes under precise. Next slide. Introduction. Sanskrit provides unambiguous grammatical rules and morphological richness. We have one example in Sanskrit, that is Rama Krishnam Pasyate. When we translate it in English, Rama sees Krishna. As we all know, Sanskrit is independent of word order. As we change the order of the word, the meaning of the sentence remains same. As Krishnam Rama Pasyati or Pasyati Rama Krishnam, Pasyati Krishnam Rama or Rama Pasyati Krishnam, it all means Rama sees Krishna. But in English, if we will change the order of the words, meaning either the meaning of the sentence gets changed or it is ungrammatical. As we can see, Rama sees Krishna. If I change the order, Krishna sees Rama, meaning change, sees Rama Krishna, unclear, and Rama Krishna sees ungrammatical. Next slide. The linguistic foundation. Sanskrit's Ashtadhyay provides a rule-based grammar model aligning with computational linguistics. Sanskrit grammatical book, that is Panini Ashtadhyay, in which that it is the rule to decide which word will become the object in a sentence. Kartur ipsi tatmam karmaha. When we are summarizing this rule, what the most desired thing for an agent, which is for subject, that will become the object. As Ramu Phalam Khadati, Ram is a subject and most desired thing for the Ram, that is Phal. So Phalam becomes the object. With accusative case, it means it is in Dvitiya Vibhakti. Advantages, reduces ambiguity and enhances interpretability. Next slide. Morphological richness. Sanskrit nouns, 8 cases in 3 numbers become 24 forms. What it means, when we are saying about a proper noun, just take an example as Rama or Balka. When we create a subgroup of these words, that is Balka or Rama, it will become in 24 forms as Rama, Ramu, Rama, Ramu, Ramu, Rama, or Balka, Balku, Balka, or Balka, Balku, Balka. It is Prathama Vibhakti to Saptami Vibhakti, and the 8th one, that is Sambodhan. What it benefits? Simplifies parsing and semantic labeling, improves machine translation and information extraction. There are 4 types of compounding in Sanskrit as Dvanda, Tatpurusha, Bahubri, and Abhyayi Bhava. But I have explained only 2 of them here. Dvanda, that is coordinated compound. When we are comparing the compounds in between Sanskrit and English, when Rama Lakshmana, when we see Rama Lakshmana in Sanskrit, it means it is one word. But when we derive this word in English, it becomes 2, Rama and Lakshmana. Already, not 2, 3, Rama and Lakshmana. Sanskrit forms one word, English uses and or hyphen. Sanskrit has dual number, English does not. What it means? When we want to say 2 boys are going, in English it is 2 boys are going, but when we try the same sentence in Sanskrit, we say only 2 words, Balakau Gachata. So Sanskrit has dual number, English does not. And the second compound, that is Tatpurusha determinative compound, that is Devalaya, house of God, that is temples. Key comparison: Sanskrit expresses relation inside the compound. Case implied: English relies on preposition of or in or apostrophe. Sanskrit structure is more compact and rule driven. Next slide. Phonology. Phonology, it means the study of the sound system of a language. In Sanskrit, one sound, one letter, and one letter, one sound. But when we compare this from English, highly irregular spelling system that is all sounds different in thorough, tough, though, and thought. Conclusion: Sanskrit is phonetically transparent, English is not. Next slide. What are the computational approaches for this NLP or AI agents? That is rule-based, statistical, HMM, CRF, neural RNN transformer, hybrid neural symbolic system. We will see one by one. That is rule-based methods. There are two parts in rule-based method, that is morphological analysis and parsing system. And there are two sub-parts in morphological analyzer, that is Sanskrit heritage platform and UH Sanskrit analyzer. What is morphological analysis? It decomposes the Sanskrit words into morphemes, identifying root, affixes, and inflectional information. And parsing system analyze sentence structures, generating syntactic trees or dependency graph. Also, there are two sub-parts of the parsing system, that is Paninian Karka parsing and dependency parsing. Next question. There are two tools available in this era. That is the first Sanskrit heritage platform. The Sanskrit heritage platform is one of the most advanced computational tools.
Please wind up, your time is up.
I will come on the conclusion. Next. What's next? These are the challenges and limitations of the research paper. That is resource scarcity. It is the most challenges. That is limited annotated corpora and standardization issue, linguistic complexity, computational challenges and interdisciplinary gaps, and the future. Next slide. And what are the future research directions? Text and speech, developing joint models for text and speech, end-to-end spoken language understanding, direct mapping from speech to semantic representation, pronunciation modeling, learning the relationship between orthography and pronunciation, procedurally aware processing, incorporating prosodic information in linguistic analysis, and the second one, text and vision, combining textual and visual information, manuscript image processing, OCR and layout analysis for historical manuscript, and some of the references I have had in this PPT. And thank you.
No question from my side. Thank you. Thank you so much.
Thank you, Oja sir, for your enriching talk, enriching presentation on how Sanskrit is a valuable resource for AI development. Our next presenter is Piyush Kumar. He will be presenting a paper titled Language, Culture, and Information Technology: The Interconnected Dynamics of Communication in the Digital Age.
Good morning, everyone. I am Piyush Kumar, and my presentation is Language, Culture, and IT, the interconnected dynamic of communication in digital era. The central thesis is IT plays dual role for linguistic innovation and a catalyst for cultural homogenization. First, we will look at the digital transformation of language. IT has created new form of communication. Think of emoticons, abbreviation, memes, optimized for speed and brevity online. This is called NetSpeak and linguistic evolution. However, this in the digital space is not culturally neutral. English dominates the internet, accounting for 60% of the global web content. This creates what we say linguistic imperialism in digital form, where minority languages are underrepresented and risk marginalization. Now, AI. AI is the frontier where language and technology converge most powerfully. Tools like ChatGPT and Google Translate facilitate for global dialogues, but they also highlight the limitations for technology. As algorithm can translate words, but often fails to capture the cultural nuances, idioms, or context-specific meaning. The problem is the core problem. Uh, Data bias, as these AI models are fed data sets predominantly sourced from uh, major languages, leaving the low resource languages behind. Now, social media. Social media platforms are where we see. Okay, thank you. Thank you so much. Social media platforms are where we see culture and identity actively constructed. This is what we say linguistic hybridity. Uh, Terms like English, Spanglish, or Tranglish illustrate the user's creativity and how they reflect their multicultural identities. However, this platform also provides social media also provides platform for cultural activism. There are hashtags like Black Lives Matters or hashtag Me Too uses language to mobilize political expression, but it also has a downside, as this same platform can sometimes spread misinformation or cultural stereotyping, which cause next is preservation. IT provides a strong vehicle for preservation. Global initiatives like UNESCO's World Atlas or Google Endangered Language Program. These creates digital resource for preservation and available for everyone. Academic communities or institutions are digitizing manuscripts and recording oral histories. This helps revitalize dying languages and share cultural heritage. In summary, the relationship between language, culture, and IT is reciprocal and transformative. We cannot simply exist it, we have to humanize it. And we we can sustain this balance by investing in multilingual infrastructure, promotes cultural sensitive AI, and encourage the digital literacy. Thank you, everyone.
Thank you for your presentation. Any question from the audience? Session chair.
No question from my side. Please continue with the next candidate.
Any question from the audience? No. Thank you, sir. Our next presenter is Sanket Kumar Singh. He will be presenting a poster titled AI-driven smart traffic management system for urban mobility optimization.
What's your name?
Sanket.
Good morning to all esteemed delegates, researchers, and distinguished guests gathered here. I am Sanket Kumar Singh from AIIT department, and it is privileged to share our work on AI-driven smart traffic management system. Global urban centers face rising congestion, demanding innovative solutions that exceeds traditional fixed timing signal systems. Our research proposes a robust adaptive framework for urban mobility optimization using a convergence of data science and IoT. The system begins with a real-time traffic data collected via IoT-based sensors and computer vision-enabled cameras deployed at intersections. This dynamic data stream is then fed to a cloud-based analytic platform for instant processing and pattern recognition. We utilize a convolutional neural network or CNN accurately detect and classify traffic density across multiple lanes. The critical decision-making layers is powered by reinforcement learning or RL, agent that dynamically controls signal timings. This sophisticated integration allows the system to predict congestion patterns and autonomously adjust light sequence before gridlock occurs. Using the Sumo simulation platform, the prototype was rigorously tested against conventional and existing adaptive models. Experiment simulations consecutively demonstrates a significant 25 to 35% reduction in the average waiting time at major intersections. Furthermore, the AI model efficiently adapts to sudden changes, showcasing superior resilience during high variability traffic events. The principles optimize dynamic resource allocation and swift command and control are directly transferable to defense logistics and strategic urban planning. Therefore, AI-driven traffic management system is not just a mobility solution, but a foundational technology for building truly resilient and intelligent metropolitan system. Thank you.
Okay, so how will you manage? So one question from how will you manage the latency part when the data is coming from the sensor and send it for the processing? How will you overcome that latency?
Sir?
There is a latency when data is coming from the sensors and go for the processing with the cloud. So there is a latency. How will you overcome that latency?
Sir, I'm just gathering information about this and I'll do work.
So see, the result comes in a real time. Okay, got it, real time. But the time have been taken due to that latency. How will you manage that the delay that occurred due to the transmission?
Sir,
See,
there will be IoT-based sensors.
with this approach, you cannot do it within a real time. If it is not in real time, that is okay. But if you want to go with a real time, but that is not possible with the cloud-based solution that have you mentioned in the paper. As well as
So they will change the density of the function.
see, as well as there is no implementation. And what are the models that have been used for this? What are the AI models that have you used for this?
Sir, they will change the density of traffic then.
So, which model do you use inside your research work?
Sir, it works on Sumo simulation platform, sir.
Okay, next thank you so much. Thank you.
Thank you, Sanket, for your presentation. Thank you, sir, for your questions. Any questions from the audience? Our next presenter is Anish Raj and Shamil Kumari. They will be presenting a paper titled AI-driven sentiment analysis for improving citizen satisfaction in e-governance. Over to you.
मैं भेजता हूँ एक सेकंड अभी थोड़ा ये इधर लगा रहा हूँ
A very cool, charming, refreshing, and delightful good morning to one and all present over here. Today, I, Shambhavi Kumari, the student of AISB, Amity Patna, along with my research partner Anish Raj, will be presenting on AI-powered sentiment analysis and how it improves citizen experience on government platforms. Before I begin, I want to start with a short story. A few months ago, a citizen named Ravi felt online about a delayed refund. The system only read his words, not his frustration. But imagine if the platform could understand emotions, identify urgency, and respond faster. This is exactly where AI-powered sentiment analysis become powerful. So today I'll walk you through how this technology works, why it matters, and what we have found from our analysis. The agenda of today's presentation will be challenges in government service delivery, scale and efficiency of Indian digital platforms, AI implementation and its impact, findings and recommendations. Now, next slide. Challenges in government services. Government departments deal with extremely large volumes of data. Manual processing is slow, time consuming, and often result in delays. Two studies shows a 70% efficiency gap between manual processes and AI-supported systems. Platforms like MyGov receive millions of feedbacks entries, making manual analysis almost impossible. AI helps bridge this gap by reducing errors, improving response time, and increasing accuracy. Scale of Indian government plan. India has some of the world's largest digital government platforms like MyGov, API Setu, and Meri Pehchan. Due to their massive user base and data volume, intelligent automation becomes essential for efficient service delivery. 75% efficiency improvement with AI. AI-powered solution improve processing speed by 75%. This results in faster decision making, reduced manual workload, and higher accuracy in data analysis. Citizens receive quicker responses and more reliable service outcomes. Moving to the next slide, global evidence of AI evidence, which is 30% of reduction. Globally, government experiencing similar improvements. For example, UK Council observed a 30% of reduction in processing time and operational cost after implementing AI systems. These improvements directly contribute to stronger public trust and better service quality. Moving to the next slide, I talk about 86% increase in citizen satisfaction. With the AI integration, many government departments had recorded an 86% increase in citizen satisfaction level. Key reasons include faster response time, accurate ticket routing, and same-day resolution for many issues. This demonstrates that how AI can directly influence public presentation and service quality. Moving to the next slide, I'll talk about AI sentiment analysis workflow. This workflow works in three ways. First, the collection, the second one is cleaning, and the third one is understanding. This workflow ensures that insights are both accurate and actionable. Moving to the next slide, I'll talk about the technical framework. Our analysis use modern AI technologies, including BERT, Robert, and Apache Spark. These tools also help us process massive data set efficiently and deliver reliable insight. There's a case study of Jammu Municipal Corporation. The Jammu Municipal Corporation implemented digital processes that leads to a 75% improvement in grievances resolution efficiency. Citations receive faster response, overall satisfaction level, and increase significantly. Citation response, this case study shows that the real world impact of adopting AI-driven system. The citation complaints are our analysis of citation feedback highlighted several recovery issues. The first one is long processing delays. The second one is confusing website navigation. The third one is slow staff response. The fourth, limited service accessibility. Fifth, lack of clarity in document requirements. AI-based systems help address each of these by improving routing, automate, communication, and enabling smart service interaction. What citizen value the most? Sentiment data, citizen consistently value first, transparency in communication, speed in service delivery, regular updates on application status, multi-channel accessibility, easy to use service platform. AI direct supports these expectations and strengthen the service experience. Moving to the next slide, I'll talk about the 150% return on investment. This ROI was achieved through increased efficiency, reduced operational cost, improved citizen satisfaction, faster grievances resolution. This proves that investing in AI is not just beneficial, it is financially strategic. Key findings and the recommendations. But the key findings are AI significantly boosts efficiency and accuracy. Systems are scalable and adaptable to multiple platforms. And the recommendations are broader AI adoption across government departments, real-time sentiment monitoring, and multi-language AI support for citizens. Thank you. Thank you so much for your attention. If you have any question, I'll be happy to answer all of them. Thank you so much.
One question from my side. What is confusion matrix?
Sorry?
What is confusion matrix? And how would you interpret it with sentiment task?
Sorry, you are not audible, sir.
What is confusion matrix? Am I audible now? What
Yeah.
is confusion matrix and how would you interpret it for sentiment task?
So as we are doing manual work, whatever we will do, collect the data, then we will analyze by the AI and also that will use to collaborate and we will help government or citizen in the various and fast response.
Okay, thank you so much.
Thank you, Shambi and Anish, for your presentation and for all who joined us. Any questions from the audience? Any questions from the audience? Thank you so much, all the presenters. Thank you so much, all the presenters, for your presentation. Okay, one more presenter is left.
Today, I'm delighted to share my thoughts on a topic that affects us all. My topic is the impact of artificial intelligence on language and communication. Language is the essence of who we are. Moving to the slide. Language is the essence of who we are. It shapes our thoughts, our identities, and our societies. Throughout history, every major technological change, from the printing press to the internet, it has transformed how we communicate. And today, artificial intelligence marks the next great leap. Unlike earlier technologies that merely transmitted messages, but now AI interpret, generate, and even anticipates them. We can see it all around us, like ChatGPT, Google Translate, and Grammarly also. We can see in Gemini how AI technology is we are using on this era. Moving to next slide, yes. From 1950s to 1970s, machine could only recognize simply patterns or translate words secretly. But by the 2000, the statistical mode made translations more accurate. And since the 2010s, neural networks and transformers models like GPT have enabled machine to grasp context. Today, AI power almost everything we do, from voice assistants to chat bots to real-time transcription and automation journalism. Next slide is how AI transform language. AI is changed not only how we communicate, but also the language itself. First, it introduces new vocabulary, words like deepfake, algorithmic bias, and prompt engineering did not exist before. But AI also tends to standardize expression, guiding us toward commonplace through predictive text and autocomplete. Secondly, translation. AI tools such as Google Translate and DeepL have made multilingual communication easier than ever. They help us collaborate across borders, yet they still struggle with items, humor, and emotional nuances. And third, in education, AI-driven platforms like Duolingo or GPT have revolutionized language learning. They personalize lesson, provide instant feedback, and build confidence. But over-reliance can reduce genuine interaction. Now we move to next slide. AI in communication dynamics. We now talk to machines, and surprisingly, we often treat them like people. Studies show that users form emotional attachments to virtual assistants such as Alexa or Siri. They comfort, guide, and even entertain us, blurring the line between human and machine interaction. On social media, AI algorithms decide what we see and believe, creating echo member. This affect not just personal communication but also public discourse and democracy. If we stay on reels for 20 seconds, same types of reel will come in next feed. That types of algorithm working into the artificial intelligence era. Now we move to next slide. Cognitive and psychological aspect. AI doesn't just influence what we see; it affects how we think. Tools like Grammarly or autocomplete help us write faster, but they also make us reflective. A 2022 study showed that students who relied heavily on AI produced grammatically perfect yet conceptually shallow essays. AI can analyze and mimic empathy, but it cannot feel it. This could eventually dull our sensitivity to real emotion. Now you move to next slide. Ethical and social linguistic change issues. First, linguistic inequality. Most AI models are trained on English and a few language neglecting others. Second, bias and miscommunication. AI often reproduces stereotypes from its data. Third is privacy. And finally, authenticity like deepfake and synthetic voice make it harder to trust what we see and hear. Now we move to next slide, which is future directions human AI simulation. The future of communication lies in human AI collaboration. We must design systems that combine machine intelligence with human ethics, emotion, and creativity. AI should augment, not replace, human expression, enhancing inclusivity and creativity while preserving authenticity. Now we move to conclusion. Artificial intelligence has forever changed how we use and understand language. It connects us across culture, accelerate learning, and redefine expression. But it also changes us to protect what makes community truly human, emotion, empathy, and meaning. The future is not about choosing between humans or machines, but finding harmony between them. Thank you.
One question from my side.
From presentation on AI in language and communication. Any question from chair session and audience?
No question. Thank you. Thank you
Any
so much.
questions? Thank you all the presenters for your presentation. Thank you audience for your valuable questions. Thank you Dr. Kalka Dubey sir for your valuable questions and presence.
Thank you so much. May I leave the meeting? No more presentation left?
Sir, could you repeat, sir?
May I leave the meeting? No presentation left?
May I leave the meeting? Yes, sir. Yes, sir. No presentation is left, sir.
Thank you so much.
चोरी कर रहा